Hi guys, welcome. This is Thedolite survey for civil engineers. Today we are discuss about the Thedolite survey. Thedolite survey is a very important and very basic for the civil engineer. So the Thedolite is a very most important, which is the most indicate and accurate instrument used for the measurement of horizontal and vertical angles. It consists of the telescope by means of which distinct objects can be sighted. The telescope has two distinct motions, one in horizontal plane and another in vertical plane. As you see that they're all the image and parts of the Thedolite has to be shown. Okay, Thedolite are permanently classified as a transist and non-transist Thedolite. Okay, so this is a very important topic of the Thedolite because transist and non-transist Thedolite is very important two topics of the Thedolite. Okay, now as we discuss, so far we have the measurement the horizontal angles by using a compass. पहले हम compass से measure करते थे with respect to meridian. Okay, magnetic meridian means north direction. ठीक है, मतलब कंपास से जब हम मेज़र करते थे तो हमें क्या मिलता था, हमें एंगल्स तो मिलता था लेकिन कभी कभी उसमें एरर्स भी आती थी. और मेरिडियन मतलब क्या है, विथ रिस्पेक्ट टू नॉर्थ डायरेक्शन. ओके, विथ रिस्पेक्ट टू नॉर्थ डायरेक्शन हम क्या करते थे, हम रीडिंग लेते थे. ओके, so far we have been measuring the horizontal angle by using a compass with respect to the magnetic meridian, which is less accurate, and also it is not possible to measure the vertical angle with respect to a compass. Okay, so when the objects are at a considerable distance or situated at a considerable elevation or depression, it becomes necessary to measure the horizontal and vertical angle more precisely. So these measurements are taken by an instrument known as the Thedolite. Okay, thus the Thedolite is used. Why Thedolite is used? To measure a vertical angle more precisely, to measure horizontal angle more precisely with respect to the as more compared with the compass. Okay, now Thedolite survey. The system of surveying in which the angle are measured with the help of the Thedolite is called as the Thedolite survey. Okay, it is very simple definition. Now, Thedolite is most accurate surveying instrument used for. What is the main use of the Thedolite survey, or what the Thedolite is used for measuring the horizontal and vertical angle? These are the main point which has been located here. Okay, for measuring the horizontal and vertical angle, for locating the point on a line, for prolongation of survey line, for finding the different level, for setting out the grades, for ranging the curves, for tachometric survey. Okay, so these are a point used for the mainly used for the what, used with the help of the Thedolite survey. Okay, which is most accurate survey, help for the accuracy of the surveying. Okay, now this is a image of the Thedolite which is shown the what are the parts of the main Thedolite. Okay, this is a tripod. Here this part is shown in this figure. This part is indicate that here some grids are to be created. With the help of that we can fix in a tripod. Okay, tripod is having the three legs. Okay, and one basic head which is consist of the hole. With the help of that we can fix the transist. This is a transist Thedolite, vertical Thedolite fixed in that. Okay, now these are the tripod legs. Okay, this is tripod head. Okay, tripod head. This is tripod. Okay, this is leveling head. The distance between the tripod to this outer spindle is to be the leveling head. Leveling head is basically consist of these screws. There are three fruit screws, this one and here is one of them. Okay, so these are three fruit screws which are used for the adjustment of the Thedolite. Okay, here some this is to be the tube. Here a tube which is to be a level tube, which with the help of that we can adjust the Thedolite vertically and horizontally. Okay, now these are the leveling screw. Okay, the leveling screw is mainly how we can adjust the theodolite with the help of the leveling screw. Okay, can see here, we for this, suppose this is one of the leveling screw, this is one of the leveling screw, and here first you have to take the your level tube. Okay, move this leveling screw inside one time, yeah, outside one time. Okay, then move this level tube for the next. Okay, move it internal or move it out. Okay, so this process done up to which when the bubble is come in a center, and after all, by after setting, rotate the theodolite in 360 degree, and see what is exactly the point of the particular level tube. Okay, if it is not in the center, then again do this procedure. If it is in center, then don't requirement to do this procedure repeated. Okay, the theodolite is consist of the lower plate, outer spindle, tri-batch, vernier AB, upper plate, eyepiece, vernier circle, turning circle, vertical clamping screw, attitude bubble, telescope, objective, and vertical axis. Okay, this vertical axis is mainly adjusted is very carefully, because with the help of this we get the proper readings. Okay, now the main scale is to be has been given here. It is obviously is of 360 degree, but the vernier scale is to be given here is to be 180 degree. While taking the readings, we are adjust the vernier scale 0 and main scale 0 coincide with each other, and vernier, and in window 1, in window 2, adjust the 180 of vernier circle and main circle 180 coincide with each other. Okay, so that's why we are getting the readings perfectly. Okay, the lower clamping screw is to be fixed at the ranging rod A, and then smoothly the leveling head has to be smoothly, the lower clamping rod is to be removed and move it to the another point, and we are taking the fixed the main portion is to be fixed at the first point A, while taking the horizontal distance, and the vernier scale is to be removed and is turned around to the next point, and we are getting the readings of point A at window 1 and point 2 at window 2, or it is only for the windows 1. Okay, now third point. So this is a transist vernier theodolite. Okay, vertical axis, upper plate, vernier, inner spindle, outer spindle, lower clamp, upper clamp, lowering plate. This is one of the detail of the upper and lower plates. Okay, now this is what the transist vertical theodolite. It is a vertical axis. We have been seen that this is horizontal axis. Side of axis mean that which the object has been seen. This is a vertical angle has to be created. Then these are the horizontal angle. These are not more requirement, and not very detail in the detail of theodolite has to be written by me in after few days. So this is just a diagram to listen up the what is a horizontal, what is vertical axis, what is a side axis of the what is vertical axis of the theodolite. Okay, now these are the classification of the theodolite. Theodolite is actually classified in a transist theodolite and non-transist theodolite. Okay, and also it is vertical theodolite or micrometer theodolite. Okay, transist theodolite to be a theodolite is called as a transist. Why it is called as transist? Theodolite, when its telescope can be transisted, that is revolve through a complete resolution about its horizontal axis in a vertical plane, whereas non-theodolite axis, the theodolite and non-transist type is to be the telescope cannot be transited. Okay, they are inferior in utility and have not become absolute. Okay, transist theodolite is to be absolute, but non-transist is not absolute. This is one of the more difference in both of them. Okay, now vernier theodolite. For reading the graduated circle, if vernier are used, the theodolite is called as a vernier theodolite. Whereas if a micrometer is provided to read the graduated circle, the same is called as a micrometer theodolite. Vernier type theodolite is commonly used. Okay, A Thedolite is designed by diameter of the graduated circle on a low plate. The common sizes are 8 cm to 12 cm, while the 14 cm to the 25 cm instruments are used for the triangulation work. Greater accuracy is achieved with a larger Theodolite, are they have bigger graduated circle with the large divisions, hence use where the survey works require high degree of accuracy. The description of a transit Theodolite is to be much more has to be attempt to me. A leveling head, lower circular plate, upper plate, telescope, vernier scale, then T-frame, pump blob. Pump blob is very used because it is used for the centering, tripod stand. Now centering, how can we make the centering? Okay, centering means the setting the Thedolite. Centering मतलब क्या, हमें Thedolite को एक जगह पे रखना है, उसको ऐसी जगह पे रखना है जहाँ से हमें हमें हर वो पॉइंट दिखे जिसको हमें मेजर करना है. ओके, एग्जैक्टली ओवर एन इंस्ट्रूमेंट स्टेशन सो दैट इट वर्टिकल एक्सिस लाइन इमीडिएटली अबव द स्टेशन मार्क. इट कैन बी डन बाय मीन्स ऑफ द पम्प ब्लॉक. पम्प ब्लॉक वी मीन वो जो एक पॉइंट रहता है जिसकी वजह से हम इसे ऐसे नीचे डालते हैं, वो 90 डिग्री नीचे जाता है, एकदम स्ट्रेट नीचे जाता है. पम्प ब्लॉक सस्पेंडेड फ्रॉम अ स्मॉल हुक अटैचमेंट टू द वर्टिकल एक्सिस ऑफ द थेडोलाइट. थेडोलाइट को एक नीचे एक हुक दिया रहता है, उस हुक को हमें वो पम्प ब्लॉक को अटैच करना पड़ता है और उसे बराबर उसे एडजस्ट करता है. द सेंटर शिफ्टेड अरेंजमेंट इज प्रोवाइडेड विद द इंस्ट्रूमेंट हेल्प इन ईजी एंड रैपिड परफॉर्मेंस ऑफ द सेंटरिंग. Transisting, it is also known as a plumbing or reversing. It is a process of turning the telescope about the horizontal axis through 180 degree in a vertical plane, thus bringing it upside down and making it point exactly in opposite direction. Swinging the telescope, it means the turning the telescope about its vertical axis in horizontal plane. That's right. Face left, if the vertical circle of the instrument is on the left side of the observer while taking a reading, the position is called as a face left. These are the very important topic, because if this PPT has to be used for the mainly purposes, then it can be used in your examination, because it is very important. Because with the help of this you can return all the questions related to the Thedolite. It is very easy and very simple to know. Okay, now changing phase, it is an operation of bringing the vertical circle to the right of the observer if originally it is to the left, and vice versa. It is done in 2 steps. First, revolve the telescope through the 180. मतलब हमें पहले 180 चेंजिंग फेस को क्या करना है, हमें 2 साइड से चेंज करना है. पहले हमारा राइट चेंज रहेगा, बाद में लेफ्ट चेंज रहेगा. तो पहले हमें राइट इससे लेना है, तो हम क्या करेंगे, पहले उसको राइट में लेंगे. इट इज डन इन 2 स्टेप. फर्स्ट, रिवॉल्व द टेलीस्कोप थ्रू द 180 इन अ वर्टिकल प्लेन एंड देन रोटेट इन इट्स टू द 180 इन अ हॉरिजॉन्टल प्लेन. First, transit the telescope, then swinging up in a 180 degree. It's a very easy topic, nothing to say anything. Now this is very important, line of collimation. Okay, it is also known as line of slide. It is an imaginary line joining the interaction of the crosshair of the diaphragm to the optical center of the object glass and continuation. Okay, axis of telescope, it is also known as an imaginary line joining the optical center of the object glass to the center of the eyepiece. Axis of the level tube, it is also called as a bubble line. It is a straight line tangential to the longitudinal curve of the level tube at the center of the tube. It is horizontal when the bubble tube is in a center. Vertical axis, it is an axis about which the telescope can be rotated in a horizontal plane. Horizontal axis, it is axis about which the telescope can be rotated in a vertical plane. Okay, and it is called as a tunination axis. Okay, these are the very now this topic is very important, because adjustment of Thedolite are a very important topic which is asked in exam, every exam. Okay, so please discuss on it. Now, temporary of the adjustment of the Thedolite. Okay, it is one of the temporary adjustment. Okay, now permanent adjustment. Okay, temporary adjustment and permanent adjustment, these are the question asking in exam very enormously, so it is very important topic. Okay, now the permanent adjustment, that means the adjustment are made to establish the relationship between fundamental line of Thedolite, and once made they last for a long time. They are essential for the accuracy of the Thedolite. Okay, it's very important topic. Now permanent adjustment in the case of a transist Thedolite are adjustment of the horizontal plate level, collimation adjustment, horizontal axis adjustment. Okay, now the axis of the plate level must be perpendicular to the vertical axis. This is to be adjustment of the horizontal plate level. Then collimation adjustment, the line of the collimation with the axis of the telescope and the axis of the object to slide and should be in the right angle to the horizontal axis. Okay, now horizontal axis adjustment, the horizontal axis adjustment must be perpendicular to the vertical axis. Okay, vertical axis. Then adjustment of the telescope level or attitude level, plate level, the axis of the plate level, telescope level or the attitude level must be parallel to the line of collimation. Vertical center index adjustment, the vertical circle vernier must be 0 when the line of collimation is horizontal. Now temporary adjustment, here only this, the centering, leveling, focusing, ordering, these are the three type used for the temporary adjustment. Next to the, these are the method for the measuring the horizontal angle: ordinary method, repetition method and retractation method. Repetition method and retractation method are very important. I just give the slides, I am not explaining because it is very long timing. Okay, so it is explained in the next topic. So thank you for watching my tutorial, and in next topic I will in detail tell about temporary adjustment, permanent adjustment, repetition method and retractation method. Thank you, and watch my video for the structural analysis 1 and so. Thank you. Bye.